Hello YouTube, RJ. Today I want to talk about a couple things. One is the AR488 project. What was it all about? What am I doing? I want to show you some software I'm developing for logging in the lab. Kind of seems like I do things random, but let me explain. The reason the AR488 project came in is because I needed a way to communicate with my newer meters, my new to me but old meters, because what I was trying to do is I wanted to get a new frequency meter for more precision for working on the oscillators, so I can better categorize, as we built these oscillators. I also wanted a better voltmeter that I could log and get very high precision from. So that's great, but if I don't have a way to log over long term for the kind of things I want to do, testing these designs and stuff that we were getting to work on, the oscillators and stuff like that, that was problematic. So once I got these, it was like, how do I get the data from them to log? So that's where the AR488 come in. Well, I want to log long term, which I've been doing, as I'm sure my longtime viewers have seen me do many times, but I have to leave the computer running. So I've got this big, powerful lab computer with high-end graphics cards, generates heat, a lot of wasted power, running 24 hours a day. And I need to edit videos and I need to do things. I need to work with the machine. And I've got it logged, and I'm always afraid I'm going to accidentally kill my logging. So it's kind of a hassle. A light bulb moment come on, and I decided that I could get all the way around this with the AR488 project. Because now that I have that little device behind my meters and I can communicate USB to them, there was no reason I couldn't write Python software for my logging and put it on a little Raspberry Pi like this and use a few watts and literally remote into this over Wi-Fi from my computer, start a logging session if I had software for that, and log out, shut my big computer down, and have it log for weeks on end. And I can use my computer all I want. It's not having any effect on the little Raspberry Pi who's logging all my data for me. So that was kind of where we were going. That was the purpose. So I bought a little plastic case for one of my spare Raspberry Pi 3 Plus Bs, and I've got it hooked up. It's plugged into the AR488 controller here, and that just stays on 24 hours a day. It's on the Wi-Fi. And so what I'm going to do today is I'm going to show you a couple things. One is I'm going to show you that and how it works and how I use it. Show the software that I'm designing for it, that I'll make the files available if it is of any benefit to anybody else. Instead of using like PyVisa or something like that that has just so much to deal with, I decided to make my own simple little programming library files that you can drop in, put an include in your own little Python program, and make it bone easy to write your own software to do any kind of logging you want to do. So that's what I did. While I want to show that to you and show how it works, I also thought it would be interesting to take a look at something while we were doing that. Everybody's experienced where their remote control quits working or their battery powered device quits working, and they leave it off and leave it alone for a little bit, and they pick it back up, and lo and behold, it works for a while. This time it works for a little bit and it quits again. If you leave it alone, it'll do it again. Now it'll run a little less time, but it'll run for a little bit. And pretty well everybody knows that's the battery recovering. Once we took the load off the battery, the voltage comes up and gets high enough to run the device again. But as soon as you put the load on, you start pulling her back down again. But I thought it would be interesting, since I've got a 6.5 digit meter over here, and I want to demonstrate logging. I thought it'd be cool to actually log that cycle and show that taking place and what it really looks like and how much the battery goes back up, and that I thought it'd be a little interesting thing to actually see that going on. So that's what we're going to do. We're going to use my logging system here with the Raspberry Pi. We're going to log that going on, and while we're logging all that, I'm going to demo and explain the software and show you what I've done. And so let's get to it. What I've got over here on the bench, how it all works. So we've got a 9-volt battery here on the bench clipped into my voltage, my 34401A digital voltmeter, and it's read 9 point. I'm going to take it out of remote mode. Let me reboot it back into manual mode so it'll update real time. So it's reading 9.0073, and we could go 6-digit there. Okay, 733. And it's sitting there, and it's pretty stably at 9.00733 volts. And so you clip straight the battery, and I've got another clip here coming over to a resistor. This is a 20K resistor here. And what I'm going to do is I'm going to, when the time comes, I'm going to clip this on and load this battery down. But I think I'm going to change that. That's about 0.4 milliamps. And I've been playing around some, so I think I'm going to load this with more. I think I'm going to change this resistor and put on what I had originally, which would quickly show us what we want to see and really dramatically show it. Let's go to about 4 milliamp draw, because this 20K resistor, just 0.4 milliamps is, it's just not enough draw to quickly show you dramatically what I want to show you. So here's a 2K, and a 2K is going to pull about 5 milliamps, which that's pretty good drain for a battery. Not, not ridiculous, but it's pretty good drain. So we're going to use this, and what I'm going to do is clip it in parallel across the battery. So that, well, that was not what I want to do. There you go. So now this will go on the negative. This will clip into the negative side of the battery. And when we're ready, I'm going to clip this on. So I'm going to go over the bench now, pick it up on the computer, fire up the logging software. We'll put it on the logger. We'll let it log for a minute or so and get a beginning. And then we'll come back to the bench and we'll put a load on this battery. I'll let it log for, 10, 15 minutes. I'll pause the video and come back. We'll take the load off and let it continue to log and log for another 10 minutes. And then we can take a look at that, graph it out, and see how the drain was pulling the battery down. But the moment we took the battery out, how much the battery recovered from that. And just kind of interesting thing to see. So let me get over to the computer and let's talk about this logging software and get it logging. Okay, here we are on the computer. And what I want to show you is we're not going to be working on the main big computer. We're going to be working on the Raspberry Pi. So I'm going to use Real VNC to log into my Raspberry Pi, which I call Skippy Controller. And so here's the desktop of my Raspberry Pi. So what I'm going to do is I'm going to go over here and open up, show you this program right here is called Sample Routines. This is just me doing testing. It's a little sample program that will make it easy for someone to take this and figure out, hey, how do I use it? So let me go ahead and open that up in an IDE. And this isn't very long here. You'll notice that we've got a bunch of imports up here. We've got one AR488 config, logging, data, which I think this will be gone by the time you guys get this file. Turns out I'm not going to need to use that. But I've got two devices that I've imported. So far, the files I've been working on is for the HP34401A and for the HP531-130A. Now, this will work for the 132A also. They're, from software point of view, they're identical. But when I import these files, these are my libraries. This gives you the library to run the 34401 and the 53131. So you import them and you give them a alias. In this case, I'm calling the voltmeter and the frequency meter freq meter. So all you need to do to use this, and we're going to run this and start logging here in a second, but all you need to do is you initialize your AR488. In that, there's this config file here that I'll load and show you these files in a minute, but you never even have to load them. You just use them. The only one you'll have to ever deal with is the AR488 config. You need to change the serial port that your device is on. Now, let me open that one real quick since we're going to talk about this. Let's open this real quick and just show you. Let's open up the config file. Okay, in the config file right here, you need to name the port. Now, because I'm on a Raspberry Pi, this is my serial port. If you're running it, I can run this same software right here on the main computer and just change this to COM. I think that's COM 15 for that device. If I plug it into my USB for the computer on the hub over there. If I change this to COM 15, that's all I have to do. This software works perfectly fine on the main computer. So I'm going to go ahead and close it out instead of having it up there. So anyway, we import this. We change the serial port to your serial port of your AR488, and you're ready to roll. So you initiate, this basically opens up the COM port, does all the work getting ready. And then right here, what you do is if you're going to be logging, which is the purpose of the software, in the comma separated value file that you generate to bring up an Excel or whatever you want to work in, we want headers at the tops. So this basically, all you do is you do log header names dot append, and you put the name of the first column, the second column, the third. So since we're only doing a voltage at the moment, I'm only going to have one header, and that's voltage. Now up here it explains that you're going to get a column. The first column is always going to be date time. So you don't have to do anything with that. You're always going to have a date time in your file. So this will be date time, and then you're adding in, I'm going to have my first column be a voltage. Then you call create log header, and I've got in here to print, hey, I'm configuring my meters. You then configure your meters. In this case, the voltmeter I'm configuring, it's on channel 2. This is the GPIB address 2. That's where that meter's at. You look over here, it tells you that. Address 2, I'm configuring, the 10 is for 10 volt range, 6.5 digit, that's what the 6 here is for. 10 power line cycles, trigger immediately, auto 0 turn on, high Z input is off, that's the 10 gig input, auto range is off. Okay, now if I turn auto range on, it doesn't matter what I put here, I have to put some valid range in here, but it's going to choose the range, it'll auto range on its own, but I have it off, so I'm setting it to 10. This line is all you have to do to configure your meter. You've told it what you want it to do. After that, basically, these are all rimmed out because these are the frequency meter and resistance. So then we start the AR488 delay loop until. You put in how many milliseconds you want between each of your logs. This is 5 seconds. Do whatever you want as long as you give it enough time to do the readings you're going to take. So we're going to do a 5-second reading. If the meter returns an overrange, it's going to log overrange. So basically, once you get it configured, you got the line up here to configure. We initialize the 488, we make a log heading, we set up our loop time, and we start logging. Meter reading equals voltmeter.read the meter. Then what you do is, since meter reading is our value, there's one call called datalist.append, and you put in your meter reading in there, and it appends that data into a list for you to send to the log. And you say, well, why wouldn't you just send the value to the log? Well, it's because you might be doing a whole bunch of different meters. You might be taking a lot of readings. And so you want to be able to append the different readings in this before you log it. So once you append all your readings into the data list, you call log.log, and it logs all that data in your file. Then it delays until your 5 seconds or whatever you've put in here. This delays until that time. It doesn't delay this amount of time. It delays until that time's passed. That's why we have to call it up here. We get the time here. We say, when is now? And we tell it how long we want to wait. And it calculates out what time do I need to take the next reading. And so when you hit delay loop, it waits for this time. So if you put 0 in here, it'll go immediately because that time's already passed. So if you want to go as fast as you can, putting 0 in here will make you go as fast as you can go. But we're going to do 5-second readings. Of course, the loop just starts over again. We take another reading and we just keep taking a reading and logging it. That's all there is to this whole program. You can do anything in here you want. Take multiple readings from different meters, different settings, whatever. Let's start logging. Now, there is one difference when you get to the frequency meter. It's address, all the different things to set up. You do not set the gate time here. There's one call for configure gate time right here. Address 3, I want 5-second reading. The reason the gate time is not put in here is because it's global over all of them. And it would be confusing to make you think that you're setting up different channels to read different times. It would just be the last one you did, all of them would work. So this clearly shows you that you're setting the meter for a certain amount of time. Now you might ask, what do I do if I want to take different gate times on different channels in my logging? Well, you put this command down in the loop. You have to put it up here before you configure the frequencies. But then you come down here, and before you take each reading, you change it. So maybe I want the first one to be 1 second. Well, then I pass this and say 1 second, read my meter. Then I turn around and say, okay, see, I've got read frequency 1. I could put this gate time for a couple seconds and take this reading. I could change it to 1/10 of a second before this one, take that reading. So you can control the gate time on each reading if you want to with this command. So that's why it's separated out the way it is. Let's start logging this. So we run it on the Raspberry Pi over there. We're just remoted in, and you'll see that we're logging. It prints in the little command window and shows you what it's logging. Now I'm going to go over and open up a file explorer on the PC. This is on the main computer, not on the Raspberry Pi. That's logging away. And I want to show you that the other thing I did to make life easy for me with this is I put Samba the file sharing software on my Raspberry Pi. It's real easy to do. You go to Google, search share a file from my Windows PC to my Raspberry Pi. It'll show you right through doing it. It's very simple. Once you're done with that, you can literally map. I have a map drive to Skippy controller down here. And what that does for me is I can go straight from my PC without going into the remote software. I can just go there. Here's the program files. Here's where it puts the log, and there's the current log. So it's generated this default log, and it's generating and putting that data in there. Now, why does that matter? Well, because this thing can log, and when I'm ready to work with this on the PC, I can just copy this off of here into my PC. I can open it from here into Excel, and you'll see that in a little bit. So it makes it easy for me because it's as if it's just storing it on a drive on my computer, even though it's really storing it on the Raspberry Pi. So that's a nice little thing to make it easy for it to work for me. So this is logging away. So now what I'm gonna do is, now this is logged a few minutes with no load on it, we'll go over the bench, we're gonna hook the resistor up, and then we're gonna let this thing log for 10 minutes, come back, disconnect the resistor, log for 10 minutes. We'll come back and pull this up, chart it, and take a look at it. Okay, I'm back over on the bench, and we're gonna hook this resistor up. And so let me clip this on here and get a little load put on the battery, and I'll start my stopwatch over here so I know when 10 minutes has been. And it looks like it's going down a little. Let's see, it's 5:13. Give it 5 seconds. Let me make sure. 2:54, 0:42. Yep, she's going down a little. So let this run, for 10 minutes or so. We'll be back. All right, it's been a little over 10 minutes. Let's go ahead and disconnect the load off this rascal. And let's see if we see it starting to come back up. Oh yeah. So let's log this. I'm gonna stop this. I'm gonna go to a timer. That way I won't be 2 minutes late next time. So we're about 12 minutes on the load. Let's throw about 10 minutes on the unloaded, and I'm watching the meter climb a little here. We're logging over on the computer, on the Raspberry Pi over here is where we're really logging. So I'll be over at the computer when we pick back up in 10 minutes. And okay, we're back at the computer, and it's been just about 10 minutes, and we're still logging. Looks like it's still coming up in voltage to me too. So we're going to go ahead and stop the logging, and we'll open up and take a look at this log. Now, one of the features that I'm going to add, I haven't got to yet, is I'm going to add a feature where you can tell it how long you want it to log. Not only how often to take a log with the delayed loop until and delay loop, but I'm going to add a feature where you can tell this log for 12 hours, log whatever, and it will log and stop automatically at that point. So that's a coming feature that's, I'll have that probably by the time you guys see this video, that and a lot more is going to be added. We'll stop her here. And now what I'm going to do is I'm going to bail out of, I don't need to be in the Raspberry Pi at this point. I'm going to go ahead and bail out of the Raspberry Pi, because we're just going to go bring up our shared folder. And go to our log, and let's open up our default log. And this is where our headers are come in. Date, time's automatic. We put voltage as our second column. Here's our values. I'll go ahead and do this. I'm going to format that column as time. And you can see that it was pretty darn flat before I put the load on. And you can see that we dropped dramatically as soon as the load went on. And we quickly fell into this linear descent, dropped a little faster as the load caught on, and then the battery started holding its voltage the best it could, heading down. But the moment we took the load off, not only did the voltage drop or jump back up, it started climbing and continued to climb. And this is, so here you are, your device is working fine, your remote control is working fine, and you get down here and all of a sudden it dies. And when it does, the load comes off. You leave it setting on the arm of the chair, and we know it cut off at a voltage of, say it cut off voltage right here. Well, the voltage builds up. The chemical reaction cools down inside the battery. And if what we should have done is, and I wish I'd have done this, is put the load back on and shown that it would not go right back down to here. It would jump down to somewhere, say here. And so it would work for a little while longer until it got to here again. The same cycle would go, but next time when you load it, it might come in here and only work for a little while. And then it might come on for just barely any time at all. Eventually it won't come on at all. You'll get down low enough voltage, it just won't. But you can see how much the battery recovers after the load comes off and continues to recover. So just kind of a neat way to look at it. So anyway, trying to make this a little more interesting to show you kind of how logging can give you great visuals on what's going on with processes. Well, that's it. I hope that was interesting. I hope you enjoyed my intro to the Raspberry Pi logging through the AR488 device using gpib on my new instruments. And I hope you enjoyed the demo of the software that I'm developing to automate the lab. But most of all, I hope to see you in the next video.